So I just wanted to go through some of the answers here on factoring trinomials when a is greater than 1. This was the first assignment I gave you for factoring trinomials, and it was in lesson 7.6. So when you're factoring a trinomial, again, if it's factorable, it's going to be written as a product of binomials. Now on this one, there's no greatest common factor that we can remove. So right away, I'm thinking, okay, I need two numbers that are going to multiply to a -5 on the end, and then I'm going to need two values that are multiplying to 3p squared. Well, 3 is a prime number, so one of these two first spots needs a 3, and then I need p and p, because 3p times p is 3p squared. Again, I need the last two here, the last two positions to multiply to give me that -5 on the end. So what values multiply to -5? Well, because that's prime, it has to be 1 and -5 or -1 and +5. So we just have to try out those possibilities. So let's try -1 and +5. Obviously, that's not correct. You can see the answer key right here. But let's just try it out. What would we get if we tried those two? So we'd FOIL this. We get 3p times p is 3p squared. Multiplying the outside 2, +5 times 3p is +15p. Then we have that -1 times p for the inside 2. Getting multiplied together is -p. And the last two, -1 times 5 is -5. So these middle two here, they combine to a 14p. This is 3p squared plus 14p minus 5, and that is not the original trinomial, so this combination is incorrect. Therefore, it has to be the other combination, the only other possibility, 3p minus 5 times p plus 1, and that's how they got this answer here. So you could double check this answer as well by FOILing these out. You get 3p squared plus 3p minus 5p. That gives you, they combine to a -2p, and -5 times 1 is -5, so that is the correct answer. All right, on the next one here, again, you're looking for numbers that would multiply to -9, and then also values that would multiply to 2n squared. Well, the only possibility to get that 2n squared is to have 2n in one position and then n in the other. And then to get a -9, that is not a prime number, so we have options. We could try to put in these spots here, we could try out a -3 and +3. We could try out a +3 here and a -3 there. You could try out a -1 and a +9, or a +9 and a -1. So you try out all these combinations, and that's how you'd whittle it down to this combination working. And again, you could double check all of these by FOILing them. So you do first outside, inside, and last. The first two multiply to 2n squared. The outside 2 gives you a 6n. The inside 2 gives you a -3n, and 6n minus 3n is +3n. And the last two multiplies to -9. So that's what you're looking for as you go through these problems. So I just wanted to scroll through real quick here, and this is the one I wanted to talk about real quick. The first thing you always want to do, you always want to try to factor out the greatest common factor, the GCF, greatest common factor first. So anytime you're given a factoring problem, always look for that greatest common factor. So you have a 9 in this one, so you might want to try to see if those other values are divisible by 9, which they are not. So then you try another value that 9 is divisible by, which is 3, and these are divisible by 3. As you can see, part of the answer has a 3 on it. So you could divide out 3 as your first step, or factor out 3. So 3 times what gives you 9k squared, and that's 3k squared. 3 times what would give me a 66k, and that's a +22k. And then 3 times what would give me a 21, and that's a +7. So that would be your first step. Factor out the 3, and then just carry that 3 down in your work. So I'd have 3 on the outside, and then I'm going to factor that trinomial into a product of two binomials. So I have a 3k squared, so I need a 3k and a k in my first two positions. And in my last two, they have to multiply to a 7, a +7. So I could have a +7 and a +1, or a +1 and a +7. So I'd have to try out in these two spots, +1 and +7, or a +7 and a +1, and I'd have to see if I were to multiply those together, which combination would give me that trinomial in the previous step here. And as you can see in the answer key there, it must be a 1 and a 7, because 3k squared plus 21k plus another k, that is that 22k, and then multiply the last two to get 7. If you try a 7 here and a 1 there, you would end up with, so if I try 3k plus 7 times 3k, k plus 1, if I try this, I'd get 3k squared there, but then I get 3k plus 7k, which is a 10k. It's not 22k, so that's why this combination is no good. So that's how you get that answer here. So any other ones on here? Yep. Number 9 is another one that you can factor out a greatest common factor right away of 3. And then number 16, all of them are negative, so you can factor out a -1 right away. And also on number 18, you can factor out a 4 right away. So just a couple of problems there where you have a greatest common factor to start, but ultimately the process of getting your answer after you factor out that greatest common factor is the same. You just try your combinations for what numbers would multiply to give you that trinomial, and what values multiply to give you that trinomial. All right, so if you have any questions, feel free to email me, text, or call. My information's all on Google Classroom now, so let me know. We're going to be practicing a little bit more of this before we move forward. So you have one more assignment that will look similar to this, but I'm not going to provide you the answer key. Please try to do your best to stay off of Photomath or any other websites that will give you the answer, because you will have to be doing this on your own and fairly quickly when you're in Geometry and Algebra 2.